Hello and welcome. My name is Debbie and I'm coming to you from the Albuquerque Public Library. We're going to have some fun today building film canister rockets powered with Alka-Seltzer. Something really important I want to talk to you about is eye protection. So before we get started, I want you to get your safety glasses on. Don't forget them. Let's keep yourself safe and everybody else safe. We have a couple of different options here of glasses and goggles. Let's have some fun and get started. All right, so let's talk a little bit about materials. What are you going to need for this experiment? Well, first off, you're going to need some kind of canister with a snapping lid. We're going to use a film canister today. If you don't have a film canister though, some other things you might be able to use are maybe some empty M&M containers, candy containers, or maybe even a glue stick container. The important point is that you have a tight fitting lid that snaps onto your canister. Okay, what else do you need? Well, you're going to need some tape, you're going to need some scissors, you're going to need some water, maybe a measuring device so you can measure the amount of water, and you're going to need some Alka-Seltzer. The other part of this is a template, and we have a nice template here. It's fun to jazz it up a little bit and use two different colors so that your rocket's fun to look at. All right, so I've already cut my pieces out of my template. So let's go ahead and start by building our rocket. Let's take our film canister. We're going to wrap the fuselage around the canister. We're just going to put some tape on. Real important trick here I've learned is to leave a little bit of space at the base so that the paper doesn't get in the way of snapping your lid on. All right, we want successful launches. Okay, so there we go. Now let's attach our fins. Neat trick I've learned with fins is if you fold them, it makes it a little bit easier to apply them to the body of your rocket. Does anybody out there know what fins are used for in rocket launching? Fins are actually used for stabilization and steering, okay? I'm just gonna use 2 fins today just for purposes of making this quick, but you can use 3 or 4, however many you want to use. You're the designer, you get to design your rocket. So here we have our second fin on. It's starting to look like a rocket. There we go. Last part is the nose cone. All right, the nose cone is simply a circle with a 90-degree angle cut out of it. Okay, let's go ahead and make our nose cone. Does anybody know what the nose cone is used for? The nose cone actually helps the rocket slice through the air, and it eliminates aerodynamic drag, because aerodynamic drag would be a drag. Here we go. Let's apply our nose cone. Sometimes this trips people up. It's really simple. Just put a couple of pieces of tape on there, smush this down, that's a scientific term, and attach. There you go, voila, we have a rocket. All right, so let's talk a little bit now about the science behind your rocket launch. First thing we have is we have a chemical reaction. So let me demonstrate this chemical reaction. I'm going to take some water here. All right, and we're going to take our fizzing effervescent tablets, Alka-Seltzer. You can use the generic brand, anything will work. We're going to drop them into the water. You see that? Look at that. That is a chemical reaction. That's actually the release of carbon dioxide gas. So think about it. When you have this release of carbon dioxide gas in an enclosed container like your film canister rocket, the carbon dioxide builds and expands until there's no place else for it to go, and it causes a reaction, okay? That brings us to Isaac Newton's third law of motion. And what Isaac Newton's third law of motion says is that for every action or force in nature, there's an equal and opposite reaction. That's important, so let me repeat that again. For every action or force in nature, there's an equal and opposite reaction. So here we have our film canister. We've got carbon dioxide gas building up. The film canister is pressing against the table that it's sitting on, and the table is pressing against the film canister, and it causes just enough thrust or the liftoff of your film canister. So before we head outside, let's go over the procedure real quick. First, we're going to do is we're going to put on our safety glasses, okay? Then we're going to put some water into our rocket. We're going to drop in the fuel source, snap the lid on, put it down on the desk, step back, and watch the rocket take off, okay? So let's head outside and let's go launch some rockets. Hello again, we're outside ready to launch our rockets. First thing, let's put our safety glasses on. We're gonna practice snapping our lid on. Okay, let's try it again because this is really important. All right, ready? Here we go. 10 milliliters of water. We're gonna drop in our fuel source. And step back. That was a blast. Har, har, har. Let's talk a little bit about what we can do to change up our scientific experiment, okay? We can use a smaller amount of water. While we were outside, we used about 10 milliliters of water. Maybe we can use half that amount or maybe double that amount and see what effect that has on our rocket experiment. We can also use more or less fuel source. We used a whole tablet of Alka-Seltzer. Maybe we can use half that or a quarter of that and see how high we go. And maybe third and finally, another factor we can use is we can change up the paper. If we use heavier paper or more tape, that could change the weight of the rocket and have an effect on it. Hey, listen, we hope you had a good time. We sure had fun with you. If you like this, be sure you subscribe to our YouTube channel and come on back to the Albuquerque Public Library for more fun digital programming. Bye-bye.